Unit rate and proportional relationships review. In this review, we're going to go over unit rate, proportional graphs, proportional tables, and constant of proportionality. So first, we're going to talk about unit rate. Unit rate is determining how many things per one thing. So the most common is miles per hour. You will also see this often in the grocery store. So it's just comparing two units. So in this first example, I have cupcakes to classes. So what I need to determine is how many cupcakes in one class. And to do this, we're going to divide top by bottom. So I'm going to do 180 divided by 12, which is going to give me 15. So that means I have 15 cupcakes for one class. I'm always required to have units, cupcakes to class, because this is unit rate, and 1 is always going to be on the bottom no matter what I do. Now for example 2, I have 72 puppies for 18 dogs. So what I want to do is figure out how many puppies for one dog. So again, I'm going to divide top by bottom. 72 divided by 18 is going to give me 4. That means 4 puppies for one dog. Okay. Next, we have proportional tables, determining if a table is proportional. So we need to look at our table. We have an XY table. My X's are 2, 4, 6, and 8. My Y's are 24, 48, 72, and 96. So again, we need to divide. This time we're going to divide backwards. So whenever I see proportional, I always need to think Y divided by X. I'm always dividing backwards. So for this first one, I'm going to do 24 divided by 2, which gives me 12. 48 divided by 4, 12 again. 72 divided by 6, 12. 96 divided by 8, 12. Because I have this repeated number, I can write my equation. So in this case, my equation is always going to be in the form y equals kx. Looks weird. The only thing that matters is this k, which is called my constant of proportionality. In this case, my equation is going to be y equals that repeated number, that 12, x. It's as simple as that. For example 2, I have to determine if the table is proportional again. So again, I'm going to divide backwards. 125 divided by 5, which gives me 25. 250 divided by 10, 25. 360 divided by 15, 500 divided by 20. Now, immediately I see that this 24 is different. That means it is not proportional. And I cannot write an equation because I wouldn't know which number to enter into my equation. Once I have a proportional relationship, I can complete my table. So for example 1, it tells me complete the proportional table. So already it tells me it's going to work out. So I need to divide backwards again. 24 divided by 3 gives me 8. 56 divided by 7 gives me 8. So in this case, my equation is y equals 8x. So if I'm solving for x, I need to divide. And if I'm solving for y, I need to multiply. And I always start with my original. That given information. So when I look at the missing y here, so because I'm missing y, I need to multiply. They gave me a 10, and I need to multiply it by the number in my equation, which is 8. 10 times 8 is 80. In this case, I'm missing an x, which means I have to divide. My given number was 72. divide that by the number in my equation, my 8, which gives me 9, and my table is complete. I have another table. This time I have decimals. Decimals are not a bad thing. Again, I have to divided by 15 is going to give me 1.5. And divide here, check it, 1.5 again. So my equation is y equals 1.5x. And I'm going to use that 1.5 to solve for my missing x and my y. So in this case, I'm missing an x, which means I'm going to divide 19.5 divided by 1.5, which gives me 13. Oops. And here I have a missing y, so I'm going to multiply. I'm given a 6 times 1.5, which gives me 9. Constant of proportionality, like we said, is that number inside my equation. So in this case, my answer is 5. And in this case, my answer is 1.25. Not very hard, you just got to find that number. Determining if a graph is proportional is pretty easy. It's very visual. You do have some requirements. So number 1, it has to start at the origin. So your origin can be in different places. Sometimes it's going to be here, where my two x and y axes meet. Or if they only gave me my first quadrant, it's going to be here in this corner. My second rule is that it has to be a straight line. So I'm always going to have a straight line, whether it's going sideways or diagonally, but it has to be straight. No edges, no wiggles. And my final rule is that I cannot have any negatives. So it always has to go towards my upper corner. So I cannot go down by any means. So it can go up like this, can go up slowly, but it cannot go down. Right, so determining if a graph is proportional. So this does not start at my origin, so it is a no. This starts at my origin, it is a line, it does not go down, so it is a yes. This has a bend in it, so it is a no. This goes down, so it does not work. Curves in it, so it doesn't work, it is not proportional. This starts at my origin, it's a straight line going up, so yes, it works. Easy as that. And finally, writing the equation of a graph. So a big part of this is to remember what my equation is. It's always going to be that y equals kx, and I have to figure out what that k is. When I look at my graph, I have all of these points, so how to write these points. Remember, this is my x, my y, x always comes in 14. 642. 1070. And 12. You do not have to find all the points, you only have to pick one point. Sometimes it's even. So what I'm going to do is I'm going to pick 642. Remember, this is my x, this is my y, and my equation, or to write my equation, I have to always do y divided by x. So in this case, I'm going to do 42 divided by 6, which gives me 7. So my equation is y equals 7x. Okay, moving on to my second example, I'm just going to pick one point this time. So with my top point, that point is 20. That's my x, that's my y. And again, I'm going to do y divided by x, so 16 divided by 20. It's going to give me 0.8. Just because it's a decimal doesn't mean there's anything wrong with it, so y equals 0.8x. Pretty simple.